Welcome to another episode of CUDA Education. I intend for this video to be a quick video, very quick video. And I'm just trying to get the ball rolling on the ray tracing reflections application. So, as you might surmise, we're basically dealing with um, rays being shot into a scene and it being reflected in some way. So we're not just passing rays into a scene and it being reflected like once, but multiple times, right? So as you could see, this this object is like a mirror and it's reflecting the objects around it, right? This sphere is also a mirror and it's reflecting the things around it. All right. Uh, you could see we have a light source up here, but on the rear side of the sphere, notice that we don't see the light source because this is reflecting the back of the sphere. All right. I just decided that it would be wise to start this process, this series, just because it would be good to do so. So that's all it is. It's reflecting rays. In this case, it's 4 times. So the recursion depth for the application is 4 times we reflect stuff. Okay. So and it all centers around this max recursion variable. Okay, so max recursion is 4. All right, that's all the application is. It's ray traced. You know, we're still on the ray tracing bit, but we're going 4 reflections deep. All right, so you guys have to intellectually figure out now what happens when we start cutting back the number of recursions or reflections in our scene. All right. So that's your homework right now. It's a pop quiz. You guys have to figure out what happens. How does this scene change? How does the scene change when we start cutting back on the number of recursions or the number of reflections that we have in our application? All right. You guys have to start to um, figure out what happens, how does the scene change when we start cutting back on the number of recursions, reflections, however you want to call it, in our scene. All right, so let's start with the number 0. All right, so now we are not allowing, max recursion is set at 0. And we are now going to see how our application reacts to this assertion. Ready? 1, 2, 3, go. If we set max recursion to 0, we get a blank screen. There's nothing in our application. That intellectually makes sense, right? Um, the rays shoot out of the scene, the rays shoot out of the camera, and we're not allowing the rays to reflect. Um, or there's zero recursion, right? I don't want to say too much because I'm still trying to fully understand the verbiage and the language. We don't even have the mist shaders showing anything, right? We don't have the sky model, nothing is showing, right? So that's also a consideration. I mean, max recursion is zero, but some could argue, well, what about the mist shaders and stuff, right? But nothing is being, I guess, reflected back to the camera, so our eyes, the monitor, we don't see anything, right? Let us graduate to the number 1. So now we have max recursion set to 1. What happens to our application when we have a reflection, a recursion, or what have you to 1? State your claim and hold your peace. State your claim and hold your peace. When we set it to 1, what happens to our application? Well, we get something like this. Okay, so the first thing is that we get a sky model, right? So I'm assuming these are all mist rays. Okay, so we do get that. We get the color of the procedurally generated spheres. I'm going to go out on a limb and assume that these are procedurally generated spheres, right? We get the color of this procedurally generated spheres, which is sort of an inherent, it's an inherent color upon creation of the sphere. Okay, so it's not like, I don't know. It's the inherent color of the sphere, but everything else is blacked out. We see our tea dispenser is completely black. We see the sphere that was like a mirror, completely black. We see the floor completely black. And we see our other sphere that was also like a mirror, completely black. Right? Not too sure. Not too sure about the floor, right? I don't know why why the floor would be completely black, but that's your guys' homework. You guys gotta, in the comments, you gotta tell me why. Come on, I can't do all the work myself. You guys gotta do some of the work too. Why is I could understand the spheres, right? Because those are like mirrors, and I could understand the teapot, but what's the deal with this guy, right? Isn't that the, like, at least the black patches, right? The black patches. Well, I guess the black patch. Well, okay, you guys have to figure it out. But my guess is that the black patches are black, and then the mirrored patches are also black. So the whole thing is black. Okay, that makes sense. So the black patches are black, and the mirrored patches are also black. So everything is black. All right. So that's probably why the floor is black. All right, makes sense. All right, let's graduate to the number 2. All right, so now we have a recursion depth of 2. We are now allowing 2 reflections. State your claim and hold your peace. State your claim and hold your peace. When the max number of reflections is 2, what do we get in our application? If you guessed this, you are correct. All right. So we get our spheres, but that's just number 1, right? We do get our teacup, and we do get the mirrored sort of sheen on the tea dispenser, right? I don't even know what you call it, tea dispenser. Uh, um, we do get a mirrored sheen on it, but so we get the mirrored sheen on it for the sky. So the sky just counts. You know, it's within the two reflections. The procedurally generated sphere counts as within the two reflections. However, the floor the floor is not counted in the dispenser, in the tea dispenser. Um, it's not counted, so we get an all black surface here. Um, so camera shoots to teacup, teacup. Camera shoots to teacup. Sky model shoots to teacup, and we see the sky. Camera shoots to floor. Floor reflects onto the teacup, onto the tea dispenser, but then the tea dis- but then that reflection is null and void. So camera shoots. Okay, so wait, camera shoots to sky. Sky shoots to yeah. Camera shoots to floor. Floor shoots to tea dispenser, but then tea dispenser does not shoot back to camera. So we get a black floor. We also we also get black spheres for the mirrors, which I think that makes sense because you're bouncing, you're trying to bounce back from the mirror back to the thing and whatever. So it doesn't see that this is too many reflections, so it gets black, right? It's null and void. Same thing for this sphere here. So it doesn't see the floor, it doesn't see the teacup. Notice that it doesn't see the tea dispenser. It doesn't see that, and it doesn't see the other sphere, right? So that makes sense. Um, and then I'm sure if we go to our other sphere, we get the same situation, right? So we don't get our teacup and all that stuff, right? So this is for number. Damn, we're only at number 2. All right, number 3. All right, so now we're at 3. Let's see what happens with 3. So we have 3 reflections or 3 recursions that are allowed. What do we see in our scene? All right, we get our full teacup, tea dispenser. Um, we see the reflected sphere. We see this the mirrored sphere is also reflecting the tea dispenser. Um, but then things get a little interesting because the reflection of the tea dispenser does not show, right? Because that's too deep. You guys gotta have to spell this stuff out in the comments. Spell this stuff out for me. You guys have to do some of this work too. It's not just me. You guys got to do some of this work. All right. So the reflection of the tea dispenser does not show on the tea dispenser. All right. This is like a tongue twister kind of stuff. This is like a riddle for you guys that like to play Myst. This is the real Myst. Okay. This That other stuff has nothing to do with, has nothing on what we're doing here. This is the real mist. Why is this not showing? You guys have to spell out the bouncing, the bounces for me. Why is this not showing? Okay. Um, we also get these streaks here still. I don't know if in our original when we did 4 we saw these dark streaks, right? But there you have it, guys. For all you creatives out there, all you artists, go call your artist friend. Okay, go call your painter friends. Go call your your artsy friends, and let them help you figure this stuff out, right? I'm technically inclined a little bit, but I'm not artistically inclined, if you get my drift. All right, so we get the reflection of the tea dispenser here, but then things get murky, right? And then here things get interesting too. All right, we got our sky model and all that stuff, right? If you look down here, we still also don't get all of this stuff, right? So that's number 3 for you guys. This stuff is losing me fast. All right, so 4 now. 4 recursions. What happens when we have 4 recursions? What happens when we have 4 recursions in our application? 4 reflections. 4 recursions are allowed. 4 recursions are allowed, guys. What do we get? We get this. That's what we get. The streaks are a little bit different, but I don't really know what's going on here. We do get a full reflection of the teacup here. The sphere now also gets this stuff, and we also get the reflection down here. And I don't know, man. Why is this still? I don't know. Okay. Let's do 10. All right. I don't think. I don't think much changes. Okay, here we go. So for the number 10, we now get a whole nother copy of the world. Right, and that's the sphere. All right, so let's go back to 4. So let's just go back. We're gonna go in the opposite direction now, right? So we're at number 4. This is 4. This is 4. All right. So now we have all of this stuff, but I guess the big telltale sign is that. Oh, we still get that. Okay, we still get that. Oh, we still get it. Okay. I don't know. Let me just go back to 10 real quick. I do want to see something. All right, so we're back at 10. All right, we got. All right, so that's 10. Let's go back to 4. Four. Three. This is 3, guys. 3. Um, this is 3. Um, this is 3. So this is 2. We're going to see 2 now. 2. We've lost our reflection here. This is 2, guys. This is 2. 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 This is 1. This is 1. Um, this is 1. All right. And then 0. And that's it, guys. That's it. So anyway, if you guys want to join in on the fun and be able to install all of these examples, you need to get tutorial number 1 and tutorial number 15. Tutorial number 1 is installing the Vulkan API on your Windows-based machine with a Vulkan-capable GPU. Tutorial number 15 is installing all of these examples. If you want to be able to run the ray tracing examples, you need to make sure you have a ray tracing capable GPU. For NVIDIA, it's RTX and above GPUs. One other thing is that what I want to do, let me change back my variable to 4. What I want to do is we got to trace, we have to trace all the places that this variable goes, right? So we have the CPU side, we have the GPU side, we have the C++ side, we have the GLSL shader side, we have just the spare V side, as an exercise for us to just dive deeper into Vulkan and all the moving parts of Vulkan. We have to to explicitly appreciate all the moving parts, and specifically where this variable goes and how each piece of the puzzle gets this variable, right? We're really trying to get ahead in terms of what it is that this we're trying to get ahead in terms of, all of this Vulkan and ray tracing stuff. So it is going to be a discussion that I'll have um, in the future about this particular application, right? In a lot of ways, in my personal opinion, it seems like especially when it comes to reflections and stuff, it seems like ray tracing is more straightforward even than just like raw Vulkan, doing stuff, with Vulkan manually, right? Because you basically essentially you're just pushing I mean, obviously you have your objects in your scene, but you're just pushing rays into a scene, and then whatever happens, you know what I mean? It's computationally more expensive, but in terms of a coding, I just personally feel that the ray tracing stuff is a little bit more straightforward, because a lot of things are kind of done for you simply because of the fact that you dispatch the rays, and then whatever happens. You don't have to manually create shadows, or you don't have to, all you got to do is just make sure you dispatch the rays, and then the pieces fall where they may. But that's just my personal opinion. Obviously we'll get into it, but anyway, guys, thank you for watching. Support the channel, you know what to do. um I hope to dive deeper into this stuff, but I just wanted to get the ball rolling on this algorithm, because it's a pretty cool algorithm. Shout out to the author, of course, always. This algorithm is open source. The links will be below. um yeah, guys, investigate this algorithm. It's also on GitHub. you know think about it during the day, and we'll dive into it some more. All right. Thanks for watching. Bye.